This is Algebra 2, Year 2, 11.4 homework. So we're given this table and then we need to find the probabilities for 1 through 3. It may be helpful if you add across the rows to get your totals for each row first. So when you add across the top row that says less than high school education, you get 107. High school education, you get 224. Some college is 438. And college is 431. And then you can add those and you'll get your total number of students that you have. And when you add these four numbers, you get 1,200. Now these numbers are going to help us with the probabilities that we have to find. So number 1 is asking us the probability that a student has less than a high school education. So we're looking at our top row. That's the top row that has less than a high school education. And we added that up and we got that there were 107 total. And that's out of the 1,200 total that we had for our entire sample. So probability of 1 for having less than a high school education is going to be that 107 divided by the 1,200, which was our total. So all of the less than high school education people over the total number of people. And we'll get a decimal, and we get 0.089, which we can then change to a percent, which is 8.9%. Number 2 wants us to find the probability that someone earns over $30,000 and has less than a high school education. So, looking at our table, earns over $30,000 is our last column, and we want to know when they also have less than a high school education. So that's this 2 right here. So we want probability that they earn less than $30,000 and have less than a high school education. So that's going to be the 2 over our total, which was 1,200 again. So this probability is going to be 2 over 1,200. Again, dividing that out, we're going to get a decimal. And you'll get 0.002, which when we go to a percentage, we get 0.2%. Number 3 wants the probability of earning over $30,000 given that they only have a high school education. So for this one, we're looking at our given is that they have only a high school education. So we're looking at this row, the high school education row. Now this given number is going to be our denominator, so it's going to be on the bottom. So we found that there were 224 people that had a high school education. So 224 is going to be our bottom number. And then the part that we're interested in is those that earn over $30,000. So if we go back to our high school education, there are 14 that earn over $30,000. So we're going to put a 14 over our 224.
Can you write that one out, like we did with the formula?
Oh,
Probability of 30,000 and,
so this translates to the probability, if we're using the formula, this translates to probability of high school education and over 30,000. So that was our 14, because that's where it's both. And then that's going to be divided by the probability of your given value, which is that they have a high school education. So that's using the formula. So this 14 is when they're or that they have a high school education and they earn over 30,000, which we got this 14 from our table, divided by the probability that they were in high school, which is the 224 because we added up this row. So you get 14 over 224, and again we'll get a decimal. We get 0.0625, which we can translate to a percentage, and it is 6.25%. Moving on to number 4. Number 4, we're given this table, and we're asked to find the probabilities for 4 through 9. So again, adding up your rows may be helpful for finding these probabilities. So if we add up all the number of females, we get 334. And if we add up all of the number of males, we get 362. You can also add the columns if you want, which might be helpful for later on. So for number 4, we're asked the probability that someone plays sports given that they're a female. So again, we want to look at our given value. If we're writing this in terms of the formula, it's going to be probability that it's female, probability of being a female, and playing sports, divided by the probability of being a female. So if we write this out, if we look at our table, the probability of being a female and playing sports is given right here, because that's female and they play sports. So we have 39 is our top number. And then our bottom number is our total number of females that we found, so our 334. So we have 39 over 344. So again, we're going to put this in and get a decimal. So we'll get that this equals 0.117. And then putting this in percentage, you get 11.7%. Now the next one asks the probability of being female and playing sports. So 4 and 5 are very similar, but what 4 is asking is the probability that you're female given that you play sports. So this one, if we wrote out with the formula, would be probability of female and sports. But now we're dividing by the probability of playing sports. So if we plug in these numbers, again, our top numbers are the same. We still have 39, but now our bottom number is going to change. We're going to add up the sports column. So we have 39 and 67. So this is over 39 plus 67 that we got from our sports column. And we'll get out our decimal when we plug this into our calculator. We get 0.368, which translates to a 36.8%. So you get 36.8%. Now, moving on to number 6. 6 wants to know the probability of somebody reading given that they're a male. So this one, again, we're gonna set up using the fraction. So we have probability of male and reading divided by the probability of male. So we find the probability of male in reading. So we go to our male column and or row, and we look at the reading column. We have 76. So this is going to be 76 over our total number of males was 362. So we have 76 over 362. We'll divide that out and get our decimal. We get 0.21, which we can translate to a percentage, is 21%. Number 7, very much like 4 and 5, they look similar, but they are not the same. So this one is the probability that you're male, probability that you're male given that you read. So again, this is probability of male and reading divided by, this time, the probability of reading. So if we plug our numbers in, male and reading, again, we still have 76, but this time it's going to be over the total number that read. So 85 plus 76. And then you'll get out a decimal again, and we get 0.427, which we can change to a percentage, and is 42.7%. Number 8. What's the probability of hiking given that you're a female? So this is probability of hiking and female divided by the probability of female. So this equals, we go to our chart, the probability of being a female and hiking, we have 48. And that's divided by our total number of females, which is 334. Getting out our decimal, we get 0.144, which gives us a percentage of 14.4%. And for number 9, we're looking for the probability of hiking given that you're a male. So putting this into the formula, we get probability of hiking and male divided by the probability of male. So plugging in our numbers, we go to the chart and look for hiking and male. So we go to our male row and go to hiking. 58 hike, so it's 58 over your total number of males, which was 362. So we have 58 over 362. And we get out our decimal, we get 0.16, which translates to a 16%. Number 10. Number 10 says the senior class is 55% female and 32% of the class are females who play a competitive sport. What is the probability that a student plays a competitive sport given that the student is a female? So we have to write our conditional probability for this one. And we're asked, what is the probability that a student plays a competitive sport given that the student is a female? So that means probability of playing a competitive sport given, so that's our vertical line, that they're female. And this translates in the equation as probability of competitive sport and being female divided by the probability of being female. So from our problem, we're told that the senior class is 55% female. So that's our probability of being female. And we can leave that as a percentage, or we can change it to a decimal, either way. So we'll leave it as the 55. And then we need to know the probability of playing a competitive sport and being female. Well, that's the 32%, because it says 32% of the class are females who play a competitive sport. So 32 is our top number. We'll divide those out, and we're going to get a decimal of 0.582, which we can write as a percentage of 58.2%. And finally, number 11. Number 11 says, a softball game has 80% chance of being canceled if it rains, and a 30% chance of being canceled if there is fog when there is no rain. There is a 70% chance of fog with no rain, and a 30% chance of rain. Find the probability that there will be fog and the game will be canceled. So this one actually isn't even a conditional probability. This is a dependent probability. We're finding the probability that there will be fog and the game will be canceled. So we're finding probability of fog and canceled. So that meant that we have to find the probability of there being fog and multiply by the probability that the game will be canceled. So in our problem it says that there is a 30% chance of the game being canceled if there is fog. So that's our probability for being canceled. So we have 0.3 is our probability of being canceled. And then the probability of there being fog, there is a 70% chance of there being fog. So that's multiplied by 0.7 because we're changing these percentages to decimals. So there was a 70% chance of fog, so that's 0.7. And we just multiply these out. We get 0.21, which we can write as 21%. So there is a 21% chance that the game will be canceled and there will be fog. And we're done.